Okay, we left a few time more for our events to connect, but it is time to launch this meeting, so let's go. Hello and welcome everyone. My name is Gaël Leimer from the Royal Belgium Institute of Natural Sciences. I'm part of the FAIR-IS team in charge of communication, dissemination and outreach, and it is my pleasure to open this first FAIR-IS webinar on the first steps towards integrated use of environmental data. FAIR-IS stands for Fair Earth Sciences and Environment Services. It is a project that has been designed to be developed in collaboration with its future multidisciplinary users, the research community, policymakers, and beyond them, the whole society, that is to say you, their participants. So thank you very much for joining us today. Our objectives with this webinar are to inform you on the FAIR-IS project, to present you the project's objectives and methodology to gain visibility, and to keep in touch with you and collect your feedback to join you to the development of FAIR-IS. So we invite you all to engage with us as much as you want by asking your questions or posting your comments in the chat. They will be managed by my colleagues Corentin Lefebvre, the chat master, and Zachariah Smith is there to manage on the IT. We already invite you to help us sharing the FAIR-IS project by following our social medias, by speaking of us around you, and of course by keeping in touch with us. So I'm pretty sure you all have your smartphone not far from here. Pick it up, connect on Twitter, on YouTube, on LinkedIn, and look for FAIR-IS and add us now to your network, please. The agenda for our webinar will be as follows. We'll start with an introduction by Alessandro Rizzo, FAIR-IS project manager. Then Maria Luisa Chiosano will introduce the use cases and domains, including the pilot studies presented by their representatives, coastal water dynamics by Rainer Schlitzer, Earth Critical Zone by Giuliano Langella, Volcanospace Observatory by Marie Boischu, Ocean Biogeochemical Observation by Virginie Racapé, and Marine Omics Observation by Simon J. Cox. Marc Portier will then reveal to us what is the mythical data lake. That sounds exciting. And last but not least, Peter Thijs will inform us on the access to environmental data infrastructure services. We will have time to answer your questions, so I invite you again to engage with us in the chat. You will be kept muted during this webinar, so please ask your questions and comments in the chat. And before to give the floor to the speakers, we propose you a small challenge here. FAIR data are supposed to be findable, accessible, interoperable, and reusable. But here, badly managed data have been lost in this landscape alongside the geological hammer. You have the small pictures at the top, so you know what you're looking for. And the question is, can you find them in this landscape? If you can find them, write your name in the chat. We'll give you a few seconds now to focus on the picture and look for the lost data. You can write your name in the chat when you found them and give a rough description of where they are, like bottom left, top right, middle left, something like that. So I'm waiting for you here. We need your help to find this data. I can tell you that the data are easier to find because that's FAIR-IS, right? So it's too easy to find data. That's the whole point of this project. The geological hammer, it's a bit more tricky. As a geologist myself, I lost my hammer so many times on the field. I can tell you it's a pain. But I see people are getting the data already. That's good. And what about the hammer? I can tell you a little clue, maybe it's rather far away, far away. I'll give you a few seconds more. Good spot, Carmen, for the edge of the mountain, central part of the picture. Yes, the data are there. And the geological hammer is there. I'm really revealing that now. You see, that was hard to spot. Okay, so without any further waiting, it is my pleasure to leave the floor to Alessandro Rizzo, project manager of FAIR-IS. He will introduce the project to us. Alessandro, please, the floor is yours.
Well, thank you very much, Gaël. My name is Alessandro Rizzo. I'm the project manager of FAIR-IS. I'm going to give you some general information about the FAIR-IS project, but I think the most urgent important things is just to understand what FAIREEASE really is. And FAIREEASE is an EOSCARE related project. For those of you that are not really familiar with this acronym, EOSC stands for European Open Science Cloud, whose main objective is make open science the new normal. To do so, some major activities has been identified, among them supporting openness, enabling fairness, and enhancing federation of infrastructure. And these three dimensions are more or less the building blocks also of the FAIREEASE project. That is a project fully dedicated to the Earth System Environmental Services integration in a FAIR method. FAIR has, as you mean, Gail, stands for fundable, accessible, interoperable, and reusable. It's a project funded by the European Union through the funding mechanism Destination Infra EOSCARE, one of the 5 destinations fully dedicated to the development implementation of infrastructure in the European Union, within the Pillar 1 Excellence in Research of Horizon Europe Framework Program. The consortium of FAIREEASE is composed of 25 partners, plus 3 affiliated entities located in 9 different European Union member states and associated countries. It is a 3-year project. Activity started at the beginning of September 2022, and normally will end at the end of August 2025. But next, please. What is the rationale behind the FAIREEASE project? Taking leverage on scientific knowledge production, we can consider easily that the comparison of the Earth system is essential, is crucial to meet global challenges. Today, one of the major challenges, scientifically speaking, is to deepen this knowledge on the functioning of the Earth system and its critical thresholds. And in addition, as technology advances, a large amount of data information is produced and is available. And these data allow us to see how Earth subsystem completely interconnected. But these data are normally located in a domain-dependent repository. Then, from a technical point of view, the most urgent challenge is to break down domain silos to foster interoperability and to build bridges and crosswalks among the different subsystems. Having this in mind, next, please. Having this in mind, the overall objective of FAIREEASE is indeed to develop and operate distributed integrated services for observation and modeling of the Earth system, environment, and biodiversity, implementing close cooperation with the user community in a multidisciplinary way. For that, we identify firstly some use cases, multidisciplinary use cases that will be presented later, and we set up the so-called FAIREEASE services, one fully dedicated to the discovery and access to environmental multidisciplinary aggregated data sets, and another related to the analysis and processing of a large amount of data. Next. It is evident that this kind of development imply a lot of challenges that can be technical, but I suppose that my colleagues will be focused on this kind of challenges later, but also social challenges in terms of engagement of the different communities that are involved in the project and beyond, and the engagement of other actors that can be involved in the project and development of the different activities. For the moment, I think that I can stop there and leave the floor to my colleagues for other presentation. Then I give you back the floor, Gael, for the next presentation. Thank you very much.
Thank you very much, Alessandro. That was very clear. So we know more about FAIREASE now, and we will learn even more. I remind you that you can't speak, but you can, of course, engage with us directly in the chat. So if you want to ask questions, please write them in the chat. You can also ask questions to specific speakers by just adding their name or their pilot number, for example. We welcome now Maria Luisa Ciosano from the University Federico II of Naples, who will present us the use cases and domains. So Maria Luisa, the floor is yours for 20-25 minutes, please.
Thanks, Gael. Good morning, everybody. I am really pleased to start the introduction of WP5, Work Package 5 of Ferisi, which is one of the six work packages embedded in this project. It includes, next please, it includes all partners involved in focused on specific pilots in the project. And these pilots are embedded in the three main use cases. Each use case focused on specific Earth-related issues, its dynamics, its biogeochemical asset, and its biodiversity. I don't want to take too much time in this introduction, and I want to leave the floor to the reference persons in charge of the presentation of each of the pilot. And the first is Rainer Schlitzer, that presents the pilot coastal water dynamics embedded in the use case 1, which is Earth environmental dynamics. So Rainer, please take the floor.
Good afternoon, everybody. I'm Rainer Schlitzer from the Alfred Wegener Institute in Bremerhaven. I will give you a brief overview of the coastal water dynamics pilot. This is work we are doing together with colleagues from University of Liège and colleagues from INGV in Bologna, Italy. Next slide, please. In this pilot, we are focusing on the Northern Adriatic and the Po estuary. And we take this as a prototype system and a prototype domain that is very dynamic, and it's affected by a whole variety of processes, such as river runoff, the meteorology plays a big role, ocean currents, of course, and the biogeochemical processes inside the water column itself. So all together typically determine the outcome of certain features. And I have listed three important ones: scientific, but also socioeconomic aspects, like biological productivity in the Northern Adriatic depends on meteorology, stability in the water column, so water conditions, but also on nutrient input by rivers. So the intensity of biological productivity and the resulting size of fish stock, that's one example of this multidisciplinary aspect. Second one, uptake of atmospheric CO2 and the effect on the carbon cycle, atmospheric, but also ocean. And third, I have listed the importance of transport of suspended materials, but also hazardous substances that can come in by rivers and then are taken over by ocean circulation. And the fate of these substances depends on both how much is coming from the rivers and at what time, and then what are the currents in the ocean system that will distribute them. Northern Adriatic and the Po estuary, we thought this is a perfect area where we can study multidisciplinary processes. And really, if we want to understand features, then we need to take into account more than one discipline. The other advantage of this region is it's well monitored, and we have a wealth of data which we want to exploit. And on this slide on the right-hand side, it's a list of the data sets that we want to use. And I'm going through very quickly. Copernicus data we will use, river runoff data, EMODNet chemistry, EMODNet physics, Jericho data from the Jericho project, Sea DataNet, World Ocean Database. And we also want to benefit from the wealth of satellite sensor data that we have. And it's different kind. and they reveal features, biological, but also physical. And last but not least, we also want to include model results, both for reanalysis studies and forecasts. And in short,
Rainer, you need to conclude now, please.
So we want to extend existing tools, and we want to make them feasible to use more than one data set at a time. Correlate satellite chlorophyll with Po River discharge, improve critical climatologies, and facilitate model data comparison. Targeted users, a scientific community, some tools will be easy enough to be used by decision makers and the public. Thank you very much.
Thanks, Rainer, for your introduction that maybe highlighted also the complexity of the overall project. And I would like to leave soon the floor to the second pilot in the first use case, which is the Earth critical zone. So Dr. Giuliano Langella, could you please clarify what is the Earth critical zone and the principal aims of your pilot? Thanks. Share the, muted.
Yes, I'm here. Thank you, Marilu. Good afternoon to everybody. Let me first of all introduce Fabio Terribili and myself from both from the University of Naples Federico II in Italy, contributing to this pilot number 2 on Earth critical zone. So what's Earth critical zone? As you can see from the picture, it's the assemblage of below ground and above ground layers, such as rocks, water tables, soils, organisms, atmosphere. My team is generally involved in the development of models, putting one or more of these layers in context. Hence, in Pilot 2 in Fair Ease project, we are going to develop a new land degradation model using this. Sorry, there is a problem with my video, with putting one or more of these layers in context. Yes, the state-of-the-art of land degradation calculation can be considered the one suggested by United Nations in 2021. As you can see from this picture, in particular, it is focused on the Sustainable Development Goals Indicator 15.3.1, which is calculated by evaluating changes in 3 sub-indicators, in particular, land cover, land productivity, and carbon stock. Next slide. In Pilot 2, we will explore different implementing opportunities in terms of both algorithms and pipelines, thanks to the availability of this Earth Analytical Lab developed in Fair Ease project. This lab will enable an enhanced access to satellite data, soil data, and therefore it will foster the creation of a model for land degradation within Pilot 2. Furthermore, this lab will facilitate any subsequent operations such as validation and deployment. Next slide. In the end, the main impact is to facilitate, for instance, nations in the computation of the proportion of degraded land, contributing to get this big picture, for instance, of the land degradation all over Europe. This is possible thanks to the strong interconnection of Pilot 2 with CRISP, the CRISP Research Center, where my team is based in, dealing with Earth critical zone. It's important to highlight the strong interconnection with the land support system platform, and within which we will embed this new tool on land degradation calculation. That's all. Thank you.
Thank you, Giuliano. And I would move fast to the third pilot of the project, which is still in use case 1. And this is the volcano space observation. And the presentation will be given by Dr. Mary Boishu. So Mary, please take the floor.
Yeah, hello everyone. So I'm Marie Boishu from CNRS, University of Lille. So next slide. Yeah, please. Thank you. So this pilot is, so the Volcano Space Observatory is an interdisciplinary pilot with partners from atmospheric sciences on one hand, with the University of Lille and the National Center AERIS for Atmospheric Data and Services. And on the other part, we have the involvement of solid earth volcanology disciplines with IPGP, Institut Physique du Globe de Paris, and the Formater National Center for Solid Earth Data and Services. Next, please. So the aim of our pilot is to build a web interface for interactively analyzing a broad panel of remote sensing observations, both from space and from ground networks. And the objective is to monitor in near real time the volcanic activity. So this involves a large panel of solid earth and atmospheric science data. And the main difficulty is to have fast access to these data. Next, please. So scientifically, from remote sensing observations, we can characterize and ground deformation observations and from solid earth data and gas particle emissions from atmospheric data. So in violet here, you have an illustration of what we can get. We can have access to the deformation of the ground using interferometric radar observations from space on the left. But we also use optical imagery to track changes in the topography with time during an eruption on the right. And generally, we can have access with such data to processes such as magma transport and storage, and also the volume budgets. In a complementary manner, we have also information of gas and particles. So here you have an illustration, for example, of a tropomy observation, which informs on the abundance of sulfur dioxide gas in a volcanic plume. And combining this information so we can really monitor the volcanic activity. So next, please. So generally, the Volcano Space Observatory portal will be of interest for scientists because it facilitates data exploration with a fast access and a joint analysis of data. And it will also be a support to help hazard assessment made by volcano observatories underground. And our group worked on the 2021 eruption of La Soufrière, St. Vincent in the Antilles. So in the picture from the ground here, you can see that we had a very major eruption with a very ash-rich plume. And during the paroxysmal phase of the eruption, the observatory became blind due to instrument destruction, but also due to instrument failure, due to the very ash-rich deposits. And from space, the image below, with using geostationary satellite observation from GOES here, we could really track the explosions with time and their intensity.
Marie, you need to conclude now. I'm sorry.
Yeah, I'm concluding. So on this scheme on the right, this concerns the local volcanic hazards. But more broadly, the portal will be also important to assess atmospheric multi-scale hazards because we know that volcanoes can impact air quality, air traffic, but also climate, as exemplified by the last Unga Tunga eruption. And our group also worked on this during the project. Thank you.
So thank you, Mary. And we fast move to the second use case, which is environmental biochemical asset and pilot 4, which is a special focus on ocean. So please, Dr. Virginie Lecapé, can you introduce your pilot?
Thank you, Maria Luisa. Next, please. So this pilot focused on the biogeochemical observations, brings together several partners from POCAPOC, EuroArgo, Ifremer, OGS, and Station Zoologique Anton Doorn. Next, please. To the biogeochemical observations such as chlorophyll A, oxygen, nitrate, or pH is useful to address fundamental scientific questions regarding the health of the marine ecosystems and our climate. For example, the ocean acidification, the decrease in the oxygen minimum zone. Today, same BGC sensors are deployed in the global ocean from various autonomous platforms in yellow on the figure. There are the Argo profiling floats, gliders, seamamols, mooring. Only 28% are already usable by scientists. The remainder needs a calibration before. The qualification, calibration, and validation of the biogeochemical data represent thus a major challenge to significantly increase the volume of high-quality data available to the scientific community. That's why the Pilot 4 aims to offer a web portal of these services for data scientists. Next, please. In the recent years, BGC sensors have diversified in terms of measured parameters, and the method of data quality assessment, validation, and calibration have become more complex. Most of the methods are used in open source tools, but with various access to data sources, various languages, and are specific to a platform. These methods that are sensor dependent require an efficient access to external data like graded climatologies, model output, in-situ data, or satellite data. Applying the method requires to assemble the data in space and time using extraction and collocation. To continue their development and application, data scientists aspire to a massive, high-performance and distributed data infrastructure to combine in-situ satellite and model data. Next, please. The aim of the ferries is to perform a more efficient work by facilitating and harmonizing the data access and the standardized tool for the qualification, calibration, validation teams in order to help with delivering high-quality biogeochemical data that will be made fair. Tools deployed for the calibration will be focused on ocean biogeochemical observation, measured essentially by sensor deployed on the Argo float, the glider, or the seamamols. But this demonstrator will be designed to easily add specific standardized methodology for other variables measured on other platforms. Thank you for your attention.
Thank you, Virginie. And now we move to the third use case of the project, which is the biodiversity observation still remaining on marine environment. And Dr. Simon Cox will introduce this pilot. Thanks, Simon.
Hi, everybody. Good afternoon. I'm very pleased to be able to present this on behalf of my colleagues. We're members contribute to the European Marine Biological Research Centre, EMBRC. And we're all working on a project called the European Marine Omics Biodiversity Observation Network, which thankfully is reduced to EMOBORN. So it's the EMOBORN data that we are going to use within this project. And our aim is to provide a rich virtual research environment where these data can be exploited. So next slide, please. So EMOBORN. EMOBORN is an undertaking by EMBRC to provide continuous sampling of metagenomic data from 16 sites in Europe and beyond. And they're sampled on bi-monthly timescales, and their data is sequenced and released as using standard operating procedures with rich metadata, including essential ocean variables and essential biodiversity variables. And the idea obviously is to use standard methods and standardization in everything we do so that the data are maximally comparable. At the moment, in 2021, we have 16 sites and about 634 samples that are waiting to be sequenced, and some 152 sedimentary samples as well. There's also a component of meta barcoding here as well, which I won't go into. So in order to make the data maximally comparable, we've been part of an EOS Glyph project, an open core project, to develop a pipeline that produces data products from these data. And it's these data products that are going to be the primary data source for the VRE in the FAIR-Ease pilot. And so these data products that we're generating are taxonomic inventories and these community gene profiles. And these will come in the form of row crates, which we then intend to trivialize and use as a Sparkle endpoint for querying of these data. Next slide, please. So for the virtual research environment, which we're calling the Earth Analytics Laboratory, the idea is to make these data and these data products, to disseminate them, and also to do primary, typical visualizations and exploration of the data, biodiversity statistics, etc. But also to have a flexible environment where we can do data analysis and workflows. And it's especially important here for FAIR-Ease, where we want to integrate these data with external data sources like GBIF. And so we are going to develop a couple of exemplar services. One of those is bioprospecting, and the second one is on ecological strategies. And so I'll leave it there. Thank you. That was my 3 minutes.
Yeah, okay. Thanks, Simon. I was not sure, but thanks to all of you for your introduction of the pilots, although the very limited time. And as you all could perceive, all the pilots are focused on different aspects. Sometimes they are related. All the pilots can have real impact for science, for policy makings, but also for social and economical aspects. All exploit open data and produce novel information that could become open again and be of general interest or specific interest for several different real-life science applications. But not minor in this project, we succeeded in putting, next slide please, in putting together people from different domains, favoring the crosstalk among the different domains. And so in this environment, we can really share the expertise and the knowledge and the resources and the standards. Next slide, please. And also agreeing on the best computational methodologies, and they are improving, favoring interoperability. Of course, these kind of things are a challenge in the project that we accepted, and the preliminary result of this effort of cross-talking, next slide please, has been published in Zenodo, which is public to all. For more details concerning these efforts. And last slide, what I want to underline is that we are really convinced that the trans-domain interaction among the different partners, different experiences, different domains will favor synergies and also unexpected novel opportunities for data integration. And the common goal, of course, will be to contribute to the implementation and improvement of a competitive, fair solutions in the EOS ecosystems. So thanks to all, and we are open to questions if there are.
Yes, indeed. So thank you very much, Maria Luisa, and all pilot speakers. That's beautiful interdisciplinary science being developed within FAIR-Ease, and I hope it will inspire our audience. Corentin, I see there is some activity in the chat. Do we have questions you would like to read for our speakers, maybe?
Yeah, thank you very much, Gael, and thank you very much to all the speakers. There were a few questions, and one has been answered by Alessandro, which was, how do we address the data management plan for such a project with a lot of data coming from a lot of sources and many stakeholders involved? I think, Alessandro, you answered the questions, but if you want to add maybe a few details on that.
Thank you very much, Corentin. Indeed, it's a very important question and a very challenging question, of course, because just to deliver something that can be useful in terms of data management plan for a huge project like FAIReasy is very complex. But as you said, they provide some inputs in the chat. If you are going to have more time at the end of the meeting, eventually we can go further. But I would like to give the time to the upcoming presentation, probably just to have an overview of the project. But thank you very much for the question. It's very, very interesting. Thank you, Davide.
Any other question, Corentin?
Yes, and before we go on, there was a second question from Claire, who was asking that in all multidisciplinary data sets that we're going to use in FAIReasy, do we also include some data from humanities? And it was during Rainer's presentation, but I think it can also apply to all our pilots in FAIReasy. I don't know if anyone will use data from humanities or not.
I don't know if Rainer wants to answer, or I can give a general answer for all.
Maybe yes, Marine, please.
Yeah, no, the point is the point that of course emerged from this talk and the question maker that I miss could really understand is the importance of having this environmental information where also biodiversity is included. And of course, we are really conscious that also including human-related data would be important. This is the reasons why we are also giving these webinars to engage possible additional stakeholders or data providers that could contribute to this multi-layer information that we are organizing in the project. Of course, we are sensitive to the fact that all these aspects are also important for well-being of both humans and animals, and all sorts of information that could be included in this layer are really welcome. And to my knowledge, there is not specific collection yet dedicated to this at this moment, but we are open to collaborate with other efforts, similar efforts.
And that was all for the moment, so we can go on the floor.
Okay, thank you. Nice questions indeed. Thank you for answering them. And so it is time to welcome Marc Portier for the mythical data lake. I'm really looking forward for that one. I love the unicorn there. So please, Marc, the floor is yours for 10 minutes.
Thank you very much. Hello. Well, let me first thank you for giving me the opportunity to talk. This next section is about the technical architecture we have drafted for FAIReasy, and to try and explain the title. Inside the original project proposal, this part of the work, the technical architecture work, was actually labeled as the data lake and was assigned to work package 4. So it ended up in my lab. And I don't know if you have experienced this ever yourself in a project, but apparently 18 months after submitting the proposal, so roughly when the project started, the biggest question apparently was, what is this data lake, right? And the question behind the scenes, the more interesting one, is actually what mushrooms were we on while we were writing that proposal? Anyway, I don't have time enough to bore you with all the details of our design, and we should all be thankful for that. Next slide, please. So my aim today is only to guide you along our thought process and allow you to see how parts of it can maybe fit your own projects. In any case, the goal within FAIReasy is to make sure that both the approach we've taken, but also the resulting design can be reapplied and reused by anybody. Point being that some people have recognized what we've been doing here and jokingly dubbed it as being a decent amount of soul searching. And we kind of wear that label with pride, since it suggests a fresh and first principles approach to the problem. The point is really that we allowed ourselves not to start off, or better not to limit ourselves by any existing definition of any data lake concept. Instead, we did an in-depth investigation of the actual needs of the various pilots you have seen earlier today. This, however, did not turn out to be the easy road, because we immediately observed a lot of diversity. I probably understand that most of you already are overwhelmed a bit with all the details you got from those 5 pilots, but digging in deeper in the technical details only makes that bigger. So there was a lot of diversity, not only in terms of technology or maturity, but also a very big diversity in all the expectations that were expressed about this data lake. Next slide. And we should have not been surprised. There is, after all, a lot of confusion about these different words that are used to describe data systems, right? There seems to be a regular new fashion wave that tries to sell us a new solution by giving a different name, right? As such, it has become somewhat of a joke. People are now saying that whatever name you're using is only telling your age you're having. The boomers are still dreaming about their databases, and the Gen Z youngsters are totally into the data cloud. But we don't need to be cynical about this, because behind all these different names, there actually has been new partial solutions and insights. There has been new innovations, there have been new additions to complete the engineering toolset. And those offer more and more techniques that we can easily and freely apply to build the data systems we need, regardless of how we name them. So, next slide. This is what we did. We tried and helped battle the complexity by turning to system engineering techniques, right? And we applied some common practices from computer science. One is to find commonality and harmonization by taking a more abstract view of things, right? We totally acknowledge that the devil is in the details, and the details do matter, but looking from a distance, it also shows that all these pilots are still pretty much using the same recurring pattern of processing and storing data, and are following a functional cycle that is remarkably similar, right? A second technique, which is on the next slide, also coming from engineering, is to, I see there's a small hiccup with the slides.
Sorry, I'm facing a little
waiting.
problem here.
No problem.
I'm not sure what's
For
happening.
some reason, you're maybe,
Yes.
yeah.
Here we go. Sorry
No,
about that.
one back, please. Yes, this is one. Okay, so this is the other engineering trick, which is about hiding the implementation details behind standards, interfaces, or contracts. Sometimes people call these facades. And it might look paradoxical at first glance, but these agreements allow to replace and fine-tune certain parts of the overall solution. The remarkable result is that this allows to throw out the stuff we don't like anymore, and we can do that without affecting all the other parts. When we do that, we are actually reusing all the other parts that we are keeping. So in other words, we achieve reuse by throwing away stuff. Or even worse, we achieve durable results by actively designing each of them with the intention to be able to replace them at any time. So I hope you can get your head around that paradox, but this is a very powerful idea we have been using in our design. Next slide, please. So this is then the end result that the previous two tools brought us, is to finally settle down on this diagram, which is, in our feeling, grabbing the essence of the recurring expectations about the data lake. And recurring was people want to be able to find the answers they need and to do that in an effective way. And that translates to downloading or copying as little data as possible in the process. To do so, and to do so in a diverse, heterogeneous, big data information landscape, we identified 3 requirements. The first one is we need systems that not only offer the full set, but also provide subsets. Those are smaller fragments of the original complete data set. We need, second requirement, all these subsets to be addressable. So we can identify and download them one by one directly. And thirdly, we need a new kind of metadata scheme about these. We need some central overview, something like a route map, that captures how to get only only, well, to decide and get only those subsets that are needed to answer the question. Good, next slide then. This is the last nerdy diagram I'm going to show you today. It is the core of what we came up with as the basic infra architecture. It's even a simplified version of it. So I do invite you to have a closer look at the full document that describes it in detail and should be released shortly. But what it does, it is throwing up a number of building blocks that are capturing what we call a separation of concerns, which is a way of grouping the different functional parts that should be not mixed together into one component. And so it reveals the lines along which to divide the problem or the solution into smaller parts. And those become the individual parts that can focus on doing their specific job to help out the others, but that also can be replaced or can be fine-tuned for any specific pilot in a very specific way. So instead of giving you the details of the diagram, next slide, please. I would just like to end with these important quotes that are coming from the document I just mentioned. And hopefully, I hope these quotes can inspire you in the projects you're involved in yourself to guide your designs. All these quotes are about erasing the idea that this data lake is a physical thing. It's erasing the idea that it's one thing you can point to. It's not a single thing you can start or stop even. Instead, it is described as a set of features and functions that can add value regardless of where they are deployed. And so this data lake becomes a concept that is not a thing, but a concept that emerges from the collaborative effort between a whole range of components. So in the end, we have left the scenario of building one central data lake, and we are embracing a solution with many collaborating data lakes that can actually be tuned and optimized for each of these pilots without ignoring the possibility to have them interoperate, work together in an interoperable way. With that, I thank you for your attention, and I don't know if time still permits. I would like to invite your questions or reactions to what I just presented. Thank you.
Thank you, Mark. Yes, we do have time. Corentin, do you have any questions for us in the chat?
We do have one, and a very interesting one. Claire is asking, how do you see, Mark, but can involve the whole consortium, the added value of the EOSC in our architecture? You have 2 years to answer that.
This is a very broad and open question. We definitely have to address that finally somewhere. There is a kind of an open invitation to have that EOSC infrastructure well defined and see how we can interact with it, because in many aspects this is also a beast with a lot of heads that nobody can really understand currently or see what it's going at. But definitely it's the goal of FAIREASE, and I think it's both ways. I hope we are able to influence even maybe ideas that are currently missing in the bigger EOSC architecture. But yes, indeed, we also will just have to find a way to interact with it, with how it is working. But definitely when we are now thinking out loud about new ways of grabbing metadata, not only about data sets, but also about subsets, we don't see currently a match in the EOSC sphere already where that could land. But I'm totally open to suggestions, and it's definitely something we will have to look for in the remaining of the project. I hope that answers your question.
Any other question, Corentin? We have time for one more if we have.
Not so far, but I'm sure that until the end, people will have a lot of other questions to ask in the chat.
Okay, so it's time. Thank you, Mark. Thank you very much. And so it's time to welcome our last speaker. Peter, please, the floor is yours to present the access to environmental data infrastructure services. You have 10 minutes. Thank you.
Yeah, thanks. I wanted even to follow up on that remark around the question by saying that, in my opinion, this is EOSC. This is part of EOSC, these solutions. EOSC is not just a central core, it's just the whole facilitation of getting the data from all these data infrastructures well available and all these research infrastructures integrated. And that's what we are doing. So it's a combination. But of course, the core, like centralized AI services, they also have their place here, which could come from EOSC. So that's a link. But we can discuss further later. Okay, let's focus on on my part. It's I'm the last, and you heard about the pilots who will, in the end, in fair ease, work in a VRE with data and processing. They will have access to a data lake. Well, you heard the soul search from Mark, which is it's a combination probably of several concepts that together build a data lake. But these data lakes or quick data access services, they will need data. And what we're doing in this action is to facilitate the access to all these environmental data infrastructures that were listed by the pilots to fulfill their need of data. We have a very multidisciplinary landscape, so that's a big challenge. We have 5 pilots. They have different virtual labs. And they have different needs of data, very multidisciplinary. They go from marine data from EMOCnet up to atmospheric data from ESA, NASA, Copernicus. And to be able to facilitate the user in finding their own data that they could draw in and work with, or feeding a kind of if we need to process data for the pilots and we need to draw in, we need to make that data discoverable. So that is what we try to do. And we call that the interdisciplinary data discovery and access service, also called IDDAS. Next one, please. Thanks. So our position in that nice diagram that Mark showed is a bit central in the area of discovery of those data providers, data. We need to facilitate, if needed, an AI layer to access the data. And so we're central. Next slide. So how do we think we can support this discovery and access to data? Well, we want to do that by establishing what we call a cross-domain fair ease data discovery and access service. We do that by first exploring the needs of the data. So we've already done that. We've done a landscaping exercise with the pilots. Which data do you actually need to set up your pilot and to create your products? And what we want to do then is harvest those metadata from these infrastructures into a central metadata target model, which is probably ISO 19115 based. We build up a catalog of metadata, and we do not do that from scratch. No, we will build upon the GeoDAP broker, which is developed by CNR. And it's already powering, for example, the GEOS interface. And it's also behind the Blue Cloud, for those of you that are familiar with it. And I'll show you later a little bit more about it. And what it does is it will map the metadata elements from the original data infrastructures into a common one and then expose it. So we want to facilitate then discovery on metadata at the collection level. And then as the second level, so once you've dived into the collection, it will contact the data access APIs that are in the metadata of them. And we call that level 2. And then you can actually discover that data sets and then download them at original granularity. But what is important, we are depending on what is available, because we do not have all these infrastructures in the project, so we cannot ask them to update. So if their services are not fair and the data is not fair, we can only send recommendations. We cannot, we have to row with what we have, row with the boat that we are in. As I said, we do not start from scratch. We are building upon experiences that we've encountered in Blue Cloud Data Discovery and Access Service. And here you can see that there are about 9 data infrastructures. Here we are at 30. And they are, in the blue cloud, they're just marine oriented, but here they're multidisciplinary. So there's a bigger challenge, especially when you look to the syntax and the semantics in the metadata. Next slide, please. I'll now go quickly through a couple of examples. Here you can see how you, in the blue cloud, you can search on certain, let's say, generic elements in the metadata to first find a certain collection, in this case, oxygen details, and you go in and you find oxygen, in this case, from EuroArgo. You can browse, next one. And then you can see where the data is located, so you can drill down a little bit more to a certain area. Next slide, please. You can view the metadata of each of these collections. Next slide, please. And then if you are interested in a certain collection, you dive in and you can detail some more. You can, so depending on the infrastructure, it offers you more facets to search on. In this case, specific variables. So you can say, no, I'm only interested in data sets that offer me salinity. Next slide, please. You can see where it actually is. Next one. And then you can order them, each of these individual data sets. This is connecting to those APIs of that infrastructure. Next slide, please. And then you can select them. Next one. And then you can download them and you can draw them into your workspace in the virtual research environment. That's the idea. But then you have files at original granularity with offering you a lot of data, but you still have to work on it. So it's not a subsetting service, it's just drawing in the raw files. Next slide, please. And as I said, very easy is multidisciplinary and the data infrastructure are not involved. So we have to work with what is available. Next one. Additionally, we know that the pilots need more direct access to process data. So ideally, we would have subsetting services. So also on that data sets that we identified here that you draw in, you might want to say, no, I'm really only interested in salinity in the first 50 meters. But that means we need to set up a subsetting service. And sometimes data infrastructures, or in many cases, they already offer data access services. And what we want to do is set up a catalog of those subsetting services and offer them in the VRE so that users can then select from these subsetting services, use them, and draw in the data immediately. So this is actually an implementation of that data lake that we want to facilitate. And for that, we want to use not only human interface to search the catalog, but also machine, so that you can actually use it to connect to, for example, in a notebook, and then connect them as a workflow behind each other. Next one, please. What you probably will realize is that if the data comes from various resources and the metadata comes from various resources, they have different metadata, but they also, in the metadata, they use different domain vocabularies. For example, in the marine domain, they have different parameters, different instrument types than they would have in the volcanic or in the atmospheric domain. But they also have similarities. They probably will use the same chemical substance type. So it could be that you're interested in oxygen, both in the atmosphere and in the water. And then there's tools available, like the NERC vocabulary service, that can offer mappings. They already have first cross-domain mappings, so they call them smart mappings, from one domain to the other. And we want to make use of that as much as we can to actually set up additional mappings to support the user in finding that data. And also to, for example, to support in the when the data is retrieved in parameter and unit conversions, because that is also possible when the metadata in the subsetting service is really set up by vocabularies that you already know. This is oxygen in micromoles per liter, and somewhere else it's just a little bit different, or here's the temperature in Kelvin and there it's in Celsius. It can do automatic conversions and then really provide the users in the pilots exactly the data as they want. And we have to see how far we can get, but well, we know it's possible, but if the domains are really different, then we might run into problems, but it's still an interesting exercise. Next slide, please. Because I think this is the last one.
Yes. And I think there is a very specific question for you in the chat, isn't it, Corentin?
Yes, indeed. There is one question for Mark. We can go on earlier, but for Peter. The question by Theo is, why did you choose ISO 19115?
Well, that is at the moment, that is one of the core metadata model for the geodata broker. It's not, I said here also, for example, because we haven't decided completely. It could also be that we go to, I think, a DCAT profile. But it's, well, at least one target model. And actually, ideally, in a completely fair world, we might not need this so much anymore. But at the moment, because this geodata broker, what it does, it actually, yeah, it's a kind of a real brokering different formats into something central and then feeding out different formats. But if everything would be harmonized from the source more, yeah, then it would be less needed. But yeah, why did we choose ISO? Because it's a lot used. It's often used in all these geo network catalogs, often that are exposed by the different infrastructures. So therefore, I think ISO is it's the one behind Blue Cloud at the moment, but it hasn't been completely decided yet, if that is the one also here.
And maybe shortly to follow, because Davide has built on Theo's question. Peter, did you select a common thesaurus, sorry, or even an ontology to describe and or define the various data, and especially something that would be more generic than the NEC vocabulary that you presented?
Not yet, but this is work that NERC, the BODC team behind the NERC vocabulary service, which are in the fair impact. No, what is it? Is it fair impact or one or the other? One other RDA working groups where they are working on such thesauruses and see what is the right entry point of setting of an ontology. Because I know that from the start, of course, the NERC vocabulary service is marine based, but it's already also covering, for example, CF standards, and there's links to QUDT for units, and then the CAS system for chemical substances, and then you go across to another domain who also could use that chemical substance list, or worms for biodiversity. So it's a whole landscape of thesauruses in the end.
And Gail, I don't know if we have a very short time for the last question.
For sure, you had a question for Mark, right?
Yeah, I did. Well, Mark already answered in the chat, but for everybody to have it, it's also from Theo, who asked Mark where the data lake will be, or data lake will be installed and run. And so, Mark, if you want to give us a few insights shortly on that.
Yes, well, the question really boils down to my last slide and my explanation that there is not one thing. So it's going to be many components on many different locations. So the where question becomes, yeah, well, it's not irrelevant, because the where question is, for each of these components, is going to drive what the optimal location for that solution is going to be. And that's often driven by avoiding what I was mentioning also, avoiding large copies of data sets, but work on them locally. Now, this is the short answer. We do realize that unifying these available subsets then, and making sure they can still be accessed and found from different environments transparently, that's going to be a challenge. And it's definitely going to be a work of collaboration with the last presenter, Peter Thijsse, and the whole approach of the Discovery Service. And this is also where the whole question on what metadata is needed and is going to be required is actually open for, well, not open for grabs, but at least open for reinterpretation. Because everything that is inside the known data set schemas, like the ISO standard that was mentioned, those are mostly tuned for human consumption, right? They're about keywords and title and author and that kind of stuff, while our computer assistants discovery, we envision, really will need more technical information. What is this data about? What connections is your data set making between parts of the question that is asked? And how big is the data set and how fast can it be delivered to me? Because if you're too big or too slow, I might go with another option. So all that kind of stuff is still to be fleshed out in details, but that's definitely the kind of work we're signing up to do.
Thank you very much, Mark. And so I will close the chat session with the thank yous that were sent.
Thank you very much indeed for all speakers. It's already the end of this webinar. I'm sorry for bringing bad news, but the good news is that in the next month, we will organize more of these webinars to inform you on Fair Ease, to keep in touch with you. Again, the best way to do so is to follow our social medias, to subscribe to our newsletter. So I invite you to connect now with us, get back with to us, speak of us around you. And I feel like, Alessandro, maybe I should leave you the last word as the project manager, right? Do you have something you would like to say, Alessandro?
Thank you very much, Gael. I would like just to thank all the organizers for the excellent webinar today, and of course all the attendees, the people that took some time to keep in contact with us and to have some information on this project. Then thank you very much to all of you. I just to say something like that. Thank you, and keep in contact, of course.
Yes, we will keep in touch. Well, thank you again. I think that's the end. I hope you learned a lot about this new project. There is a lot of exciting science to come. If you have questions that comes to you after this webinar, please feel free to send them. You can also connect with us on the Fair Ease website, and we will forward your questions to any specialist that was here in this panel. Thank you again to all speakers, and I think that's the end here. Thank you very much, all.